With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so our question is, a room has 4 meter cross 4 meter cross 10 centimeter concrete roof of thermal conductivity 1.26 watt per meter per degree Celsius. At some instant the temperature outside is 46 degrees Celsius and the heat inside is 32 degrees Celsius. Neglecting the convection, calculate the amount of heat flowing per second into the room through the roof. Second part, bricks of thermal conductivity 0.65 watt per meter per degree Celsius of thickness 7.5 centimeter are laid down on the roof. Calculate the new rate of heat flow under the same temperature condition. Okay, so in the given question, what is given is we have a concrete roof, okay, whose dimensions are given to us. Okay, so let us suppose that this is our roof. Okay, this is our roof. Okay, now making this to look like a roof. Okay, just a second, let me complete the diagram of our roof. Okay, yeah, so this represents our roof, okay, whose dimensions are given to us. The dimension is, this one is the 4 meter, correct? This one is also how much? 4 meter, and the thickness given to us is 10 centimeter, or we can say it as 0.1 meter, correct? Now the thermal conductivity of this roof is given to us as K of roof is how much? 1.26 watt per meter per degree Celsius, correct? Now at some instant, what is saying that the outside temperature is theta 2 is how much? 46 degrees Celsius, and the inside temperature is theta 1 is equals to how much? 32 degree Celsius, correct? Now we have to neglect the convection, okay, and we have to calculate the amount of heat flowing per second into the room through the roof. Okay, so the heat flow will be directed towards this direction, correct, from the higher temperature to lower temperature. So for the first part, that is the heat or the amount of heat flowing per second is given as delta Q by delta T will be equals to K of the roof into area into the change in the temperature, that is theta 2 minus theta 1, divided by the thickness, correct, thickness of the roof. From here delta Q by delta T will be putting the respective value, that is 1.26 watt per meter degree Celsius into the area. Area of the heat conduction is represented by this area, correct, this area, correct. So getting the value of this is 4 cross 4, correct, so it will be 16 meter square. The change in the temperature is 46 minus 32, correct, 46 minus 32. Now thickness is 10 centimeter, that is 0.1 meter, correct. When we calculate it, we get the value of heat from the roof, that is the rate of the heat transfer to the room is 2822 watts. Okay, so this is our first part, correct. Now in the second part, what we have to tell is if brick is added on the rooftop. Okay, so let us suppose that this is the brick added on the rooftop. Okay, this is the brick added on the rooftop, correct. Now the thermal conductivity of brick is given to us is how much? 0.65 watt per meter degree Celsius. Now as we can see that the brick and the roof, the concrete roof, is making a slab, a composite slab. Okay, so to find the rate of the heat transfer, first of all find the total resistance provided by the two. Okay, now the total resistance for the B part, the total resistance of the composite slab will be resistance of the roof plus resistance of the brick, correct. Now resistance of the roof is given as 1 by Ka, 1 by K of roof into the thickness of the roof divided by area, correct, plus resistance of the brick is given by 1 by K of brick into thickness of the brick into area, correct. Now substituting the respective values, what we get is 1 upon K of brick is 1.26 into thickness of the roof is 0.1. Area we have calculated as 16, correct? Plus 1 upon K of B. K of B is given as how much? 0.65 into thickness is given as 7.5 into 10 raised power minus 2 meters divided by area is 16, correct? Now when we calculate it, the total resistance of the composite slab will come about 1.216 into 10 raised power minus 2, and the unit will be what? Degree Celsius per watt, correct? Now we have calculated the total resistance, so we can calculate the rate of the heat transfer through the composite slab, correct? This will be the change in the temperature, that is theta 1 minus theta 2, theta 2 minus theta 1 divided by the equivalent resistance. This is 46 minus 32 divided by R is 1.216 into 10 raised power minus 2. When we calculate it, we get the rate of heat transfer of the composite slab. This will come about 1152 watts. Okay, so our second part is also done with this. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.